All right. Ooh, we're up to 3x3 systems of linear equations. And if you're with me here and you're watching this, I'm going to say you deserve to learn an easier way to do these problems. You can do it all by hand using the elimination method by yourself. But if I were you, and there's a shortcut to know how to do it, I would want to know how. So I'm going to show you how. Instead of doing the elimination on all of that, I mean, there's a couple of them that aren't too bad here. To do it by hand, if we add these two together, the y's are going to drop out, right? And so we'd have 5x minus 6z. I'm adding here, so I think then that's negative 35. And 7 would make that 42. And then if I did the last two, oops, not the last two. I was going to do the first and the last because my y's will also drop out. So x, even the x's drop out. So this one might be easier even by hand, but I'll show you another method because sometimes the x drops out, the y drops out, x and negative x, y and negative y, and then we have z, and 9z is 10z equals, whoops, 50. So z is 5. And then you go back and plug that in somewhere. So I'll plug it into this one. If z is 5, I've got 5x minus 6 times 5 is 30 equals that negative 35. Add 30 over and I got a negative 5, right? 5x. So I've got x to be negative 1. And then put both of those, x plus y plus z have to add up to 7. I've got negative 1 and 5 right now, that's 4. That means my last thing, y, would be 3. So that's one way to do it. Let me show you one other way, because sometimes these might be more messy, these systems of equations. So you put this in your matrix notation. So if there's no number in front of a variable, remember that it would be like a 1. So in front of these x's, I've got 1, 4, and that negative would be a negative 1. So I put those 1, 4, negative 1. And then in front of these y's, I've got 1, negative 1, negative 1. And then in front of my z's, I've got a 1, negative 7, and 9. And they put this vertical line sometimes where those equals are here to separate your variables from the answer side. And then the 7, negative 42, 43. Now, here's how this, it's almost like cheating because you don't have to learn how to do it, but that's all right. So let's see, I'm going to go back to a just Desmos.com. I thought there was right here, I could click on it, but I don't. That's not going to give me, I want a matrix, the Desmos matrix calculator. Nope. So let's take the calculator off from the end of here. And on the Desmos.com screen, oops. Computer just says waiting. Because I get locked up. Well, let's see what's going on here. All right, I had a pop-up window that was covered up, couldn't see it. So then instead of, once you get to this window, your math tools, matrix calculator. Oh boy, now I think I lost my matrix that I wrote out, didn't I? Let's see, is it? Shoot. All right, I gotta write this matrix back out. So let me get that back. So it was 1, 4, negative 1, 1, negative 1, negative 1, 1, -7, 9, the line to separate for the equal signs, and the 7, -42, and 43. There's your matrix setup. Then we're jumping over to the Desmos matrix calculator. We're going to put a new matrix in there. And our new matrix has to have 3 rows and 4 columns, just like that. Now we type all those numbers in. I'm going to arrow to the right. 1, 1, 1, 7, 4, -1, -7, -42, -1, -1, 9, 43. And here's where it's almost like cheating. We enter that in. And then I want to put this in this RREF. It's called the reduced row echelon form. And it puts a 1 in the diagonals. And we'll talk about that here in just a second. And we're going to do that on our matrix A. And when we do it right over here, we have all our answers. So this represents the X, and it's a -1. This represents the Y, and we've got a 3. And this one is our Z, because that's the order we wrote them in over here, and that's a 5. So our answer, -1, 3, 5 for that problem. And we didn't have to, I think that's what we got when we did it. And I jumped out of there and lost what I had written on the screen when we did it by hand. But boy, again, this is almost like cheating when you get to do it like this. So, because all of the messy math that we would have had to do by hand, and I often make an arithmetic mistake and then everything is wrong, I don't have to worry about it. I just got to make sure I type everything right here. All right, let's check it out and see how we did. Excellent, well done. But that gives you a whole bunch of information on how you can do these problems for problems like that. Good luck, you guys.